Good evening, everyone. So, welcome to my YouTube channel, Math Control. So, today we are going to see second lecture on probability theory. In this lecture, we will see what are the events, what is the definition of event, and we will see what is probability of an event. Okay. So, what is event? Event. Okay. A subset of sample space S. Sample space is denoted by S. So, a subset E, a subset E of sample space S is called an event. Okay. So, for example, you see this tossing a dice, throwing a dice, throwing a dice. So, what is sample space? Throwing a dice. 1, 2, 3, 4, 5, 6. Okay. So, I am taking E is equal to 1, 3, 5. I am taking E1 and E2 I am taking 2, 4, 6. Then E1 is subset of S and E2 is also subset of S. So what does it mean? It means E1, E2 are events. Okay. So this implies E1 and E2 are events. Okay. Are events. Okay. So we have this result. You can say theorem. Let you can say it remark also. Do not say theorem. I will say it remark. Remark. If E1 and E2, or you can say A1 and B, A and B, if A and B are events, then A1 complement second A union B, third A intersection B. Okay. Okay. And and other subsets generated by A and B are also events. Are also. So it is very clear because A and B are event. You take intersection, you take complement of A, you take A union B. These are also subsets of sample space. So they are going to be event. Okay. So now, so what is probability? Sorry. So what are mutually exclusive events? Events. Two events E1 and E2 are said to be mutually exclusive if E1 intersection with E2 is nothing but I. For example, I have already written example that you take those throwing a dice. So I have sample space 1, 2, 3, 4, 5, 6. E1 is 1, 3, 5, and E2 is 2, 4, 6. So what is E1 intersection E2? So E1 intersection E2 is equal to 5. So this implies E1 and E2 are mutually exclusive. Mutually exclusive. Now we are going to see what is probability. Probability of an event. Okay. Probability of event. Okay. Probability of an event. The chances of occurrence the chance of occurrence of an event is called probability of that event. Okay, it is a numerical value and is given by probability of E is equal to number of elements in event E and number of element in sample space. Where E is event and S is sample space. Okay, so note that phi. What is the probability of phi? Because phi is always subset of sample space. So phi is an event. That is called null event. Phi is called null element. So number of elements in phi that and number of S. Number of phi means that is 0, but NS that is 0. Okay, probability of null event, it means phi is actually 0. So what is the probability of full space? Probability of S. Okay. So earlier we have shown that the probability of null event is 0. Now we have shown that probability of sample space is 1. So I'm writing another note. What is the probability of E complement, that is 1. Note 3 I'm writing. If E1 and E2 are mutually exclusive, mutually exclusive events, then probability of E1 union E2 is equal to probability of E1 plus probability of E2. Let's see its proof. Since E1 and E2 are mutually exclusive, we have E1 intersection E2 is equal to 5. So E1 is intersection E2 is 5 means what? The number of elements in E1 union E2 will be equal to number of elements in E1 plus number of elements in E2 because both are disjoint. So therefore, this implies probability of E1 union E2 is equal to probability number of elements in E1 union E2 upon NS. Okay. So what is this? NE1 plus NE2 upon NS. That is NE1 upon NS plus NE2 upon NS. So what is this? This is PE1 plus PE2. So this implies PE1 union E2 is equal to PE1 plus PE2. Okay. So they prove now. Okay. So I am writing note 4. This is note 4. Note 4 is that probability of E complement is nothing but 1 minus probability of E. So let's see its proof. We know that E union is equal to S and E intersection E complement is 5. So what does it mean? It means E1, E and E complement are mutually exclusive. So they are mutually exclusive. This implies you take probability both this side. So this is PS. PS is actually 1. So by because both are E and E complement, both are mutually exclusive. So by note 3, what we will have PE plus PE complement we will have, and PS is nothing but 1. So this implies PE complement is equal to 1 minus PE. Okay. Okay. So this is this. So what is so this is probe now. So what are mutually exclusive events? Sorry, mutually equally likely events. Equally likely events. two events E1 and E2 are said to be mutually exclusive if, sorry, are said to be equally likely events are said to be equally likely events if probability of E1 is equal to probability of E2. So you see example this. Throwing a dice. So what is S acid? 1, 2, 3, 4, 5, and 6. And what is I am taking? E1 is equal to 1, 3, 5, E2, 2, 4, 6. So what is the, so how to calculate probability of E1? So probability of E1 is nothing but number of elements in E1 upon number of elements in sample space. That is 1 upon, sorry, number of elements in E1 is how many? How many? I have 3 upon NS is 6. So that is 1 by 2. Okay. So what is PE2? Number of elements in E2 upon number of elements in S. That is 3 upon 6. That is 1 by 2. So this implies PE1 is equal to PE2. So this implies E1 and E2 are equally likely events. Okay. Equally likely events. Okay. So first of all, you observe that one thing. Probability is a non-negative thing. So I'm writing note here. Note that here. Note that NE is number of elements in is greater than 0 and number of S is in a sample space always greater than 0. So this implies probability of E is always, because NE upon NS will be greater than 0. So this implies probability is always greater than equal to 0. Okay. Also note that one thing. Note 5, I'm writing it. Okay. Note 5. Probability is always in this range. Okay. Proof. Because we have already shown P is always So, so you take E event. So then we have E event. You take E your complement is equal to S. Okay, and and E are mutually exclusive. So this implies probability of E union probability of E complement is equal to probability of S. But this is nothing but probability of E plus probability of E complement because both are mutually exclusive. Okay. So we have already shown that probability is always greater than equal to 0. Okay. So this implies, but P is less than equal to PE plus PE complement because PE complement is also will be non-negative, but this is equal to 1. But this is all okay. So what we got? We got this and this one. Okay. So we'll do one question. A pair of dice is thrown. What is the probability? Probability of getting total and even number. Solution. So S is what is the S? We are tossing a pair of dice, so we will get this order. 1, 1, 1, 2, 1, 3, 1, 4, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay. 3, 1, 3, 2, 3, 3, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now I'm taking event E. E is the event getting total even number. E is equal to getting total and even number. So E is event getting total and even number. So what is this? So this is an event so E is equal to an event getting total and even number. So what are the possibilities? 1, 1, 1, 3, okay, 1, 5, 1, 1, 1, 3, 1, 5, okay, 2, 2, 2, 4, 2, 6, okay, 3, 1, 3, 3, 3, 5, okay, 4, 2, 4, 4, 4, 6, 5, 1, 5, 3, 5, 5, 6, 2, 6, 4, 6, 6. Okay. So tell me how many numbers are there in this event? 1, 2, 3, 4, 5, 5, 5, 10, 10, and this is 10, 18 elements are there. So any has 18 elements. E has 18 elements. And how many elements in sample space? 36. So what is the probability? E. Probability of getting total and even number. So what is this probability? So this is N E N S. So what is this? This is nothing but 18 upon 36. This is 1 by 2. Okay. So probability of E is probability of E is 1 by 2. Okay. So what are the sample points? Sample points. Sample points. An outcome in the sample space is called sample point sample points or I can say or an element of the sample. Okay. So, example, so example, tossing a coin, tossing a coin. So what is sample space? S is equal to H and T. Where as H it had and T it had. So H and T are sample points. Okay. Because only outcomes are in sample space are H and T. So H and T are sample points. Another example, throwing a dice. A dice. Throwing dice, what is sample space? 1, 2, 3, 4, 5, 6. So what is the sample points? 1, 2, 3, 4, 5, 6 are sample points. Pair 1, 2, 3, 4, 5, and 6. And 6 are sample points. Okay. So, the mark, or you can know, let x is equal to x1, x2 up to xn be sample space okay, and x1, x2 up to xn are distinct sample points are distinct sample points points then probability of x1 plus probability of x2 sorry, so I should write here, let E be an event. Let E is equal to be an event and these are distinct sample points then up to is equal to probability of E. Solution proof. So put E1 is equal to EI is equal to XI for I goes to 1 to n. Okay. Then E1 union E2 union E3 up to UN is equal to E. Okay. And this are mutually exclusive. So we will have E1 union E2 union E3. Okay. Union En is equal to probability of A. But E1 and this event, whole event are mutually exclusive. Okay. Because X1, X2, Xn are distinct. Okay. So if I will take union E2 up to En, then will be that set will be subset will be mutually exclusive with E1. Okay. So what we will have? We have PE1 plus PE2 union PE3 up to En. Okay. Again, you combine this. So E2 is mutually exclusive is this one. So repeating this process, what we will get? We'll get this one. So what we will get? We will get this one. So what is E? Now write this here. X1 plus P X2 plus P Xn. Okay. Is equal to P. So this is so. Okay. So it means the probability of an event is nothing but sum of the probability of sample points. Okay. So what is weight? Weight probability of a sample point is called weight. Okay. Okay. So example, throwing a dice. What is sample space? 1, 2, 3, 4, 5, 6. Okay. So 1 is sample point here. So 1 is sample point, 2 is sample point, 3 is sample point, 4 is sample point, 4, 5, and 6 are sample points. So what are the weights? What is the probability of 1, 2, 4, 5? These are the weights. These are the. So what are the weights? Each. So what is the probability of this one? 1 probability. All three are equal. equal. What is that? Each has number of elements 1 upon divided by number of ns. What is that? 6. So this is 6. Okay. So weights are 1 upon 6. Okay. Probability of each sample point is 1 upon 6. So weights are 1 by 6 in throwing a dice. Okay. Okay. Here events are here points, sample points are equally likely events. Okay. So what we conclude? Conclusion. Probability probability. So P is nothing but if conclusion. So you can say remark also. Note you can say. Note. By previous note. By previous note or remark, what was that? By previous note. By previous note. Probability of E is nothing but P x1 plus P x2 plus P xn. Okay. So what is the meaning of this? This implies probability of an event, probability of an event is sum of the weights of sample points inside the event. Sum of all the weights sample points inside the event. Because these are nothing but sample points and we are taking probability, and that the sum of all these sample points in the sum of probability of sample points inside the event is nothing but probability of event. Okay. So probability of an event is nothing but sum of weights, and weights are taken from the that event. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you next lecture. Thank you very much.